Okay guys, so this is going to be our last video over rotational motion. We're going to talk about torque, okay? I wouldn't be a physics teacher if I didn't teach you about torque. If you're going to any sort of engineering, mechanical, civil, chemical, you have to take a statics class. And I wish I would have learned this in high school. I didn't learn this in high school. I had to teach myself. And it's not the easiest thing to learn, but we're going to do our best to give you some sort of guidance on this. Okay, so torque is a rotational equivalent of a force. It is technically an imaginary force and it's really not tangible, okay? Torque is represented by the symbol tau is equal to R times F perpendicular. Okay, so it's important to know that the radius and the force are always perpendicular to one another in order for it to have torque. Okay, so we have something called cross product. In math and so you might see it like that. Pretty much means the same thing. Cross products are always perpendicular to each other when you're doing vectors. Now we're going to do something called the right hand rule. Okay, so what you do is you orient your hand in the direction of the radius. Okay, so like in this case, on this one, my radius is going upward, right? And I need to curl my hand towards the direction of the force. So orient my hand in the direction of the radius and I curl towards the direction of the force. Okay, so it's going to the left, so I'm going to curl my fingers to the left. And my thumb is pointing upward, okay, which means that we're going in the positive z direction. Okay, so if your thumb is pointing outward, it's going to be the positive direction. If it's pointing inward, it's going to be the negative direction, okay? So out of the page is positive, in of the page is negative, okay? So we got to keep that in mind. It gets a little tricky. Now, depending on what your teacher says or the convention of your book, that might change. So we're going to ignore these arrows for now, okay? So first example, we're going to find the torque. So torque is equal to R times F, okay? So your radius is going to be the distance from the point outward, okay? So it's going to be 1, and then your force is going to be 60, okay? So your units are going to be Newton meters. Now, if we determine which direction it's going to be, if it's going to be positive or negative. So I orient my hand in the direction of the radius, and I'm going to curl towards the force. The force is going left, so my thumb's going up, so it's going to be positive. So I'm going to write a nice little positive right there, okay? And that's it. Okay, you do this in physics also, and physics too. So we got to learn how to do this right-hand rule. Okay, so torque of this. Torque is equal to R times F. Okay, so your radius in this case is going to be 3, and your force is going to be 100. So it's going to be 300 Newton meters. Now we got to determine the direction. Okay, so our radius is going this way, and my force is going upward. So I'm going to curl my fingers that way, and I'm going to be going out of the page. Okay, so it looks like my thumb's going up, but it's going out of the page. Okay, so it's going to be positive. I thought about this right before I did the video. I was like, man, this is going to look really weird on the video, okay? Now, if we have something that's directed at an angle, anytime a force is directed at an angle, we have to break it down into components. Now, we need to make sure we make the switch to degrees in our calculator because these are measured in degrees. So go to mode and change your mode. Now, we have to break it down into components. So this is going to be 50 cosine of 30 is 43.30. And then 50 sine of 30 is going to be 25 newtons. Okay, so what we're going to do is we're looking for which force is going to be perpendicular. Okay, and we can actually draw that 25 right here. Okay, so the 25 newtons is actually acting upward right there too. Okay, so which force is perpendicular to the 1 meter? Well, it's going to be the 25 newtons. Okay, this is going to be parallel. Parallel forces don't give you any sort of torque. Okay, so torque is equal to R times F. So your radius is 1. And your force is 25 newtons. So your torque is going to be 25 newton meters. Now we have to determine the direction, okay? So I'm going to orient my hand going to the left, okay, because my radius extends from here to here, and I'm going to curl upward. My thumb is going this way, so it's going to be going into the page. So it's going to be a negative. Okay. Next example problem. We got a force at angle, so we have to break it down into components. So the 60-degree angle is right there. Okay, so we're gonna use our calculator. We're gonna do 45 cosine of 60 degrees. So the cosine component is gonna be 22.5 newtons. And then our sine component, $38.97 newtons going this way. Okay, so remember, like I said earlier, this 38.97 is acting right there. We can draw it like that. So your torque. Torque is going to be your radius times your force. Okay, your radius is 2. Your force perpendicular is going to be 38.97. Okay, so 2 times 38.97, and you get 77.94. Now we're going to determine the direction. So we orient our hand in the direction of the radius. Okay, so your radius is extending this way, so it's going down, and I'm going to curl my fingers to the left. My thumb is pointing into the page, pointing that way. So if I curl this way, pointing into the page, it's going to be negative. Okay, so remember that you orient your hand in the direction of the radius and you curl towards the force. Okay, so it's going into the page. Right hand rule is tricky. You're going to be using it for a lot of things in physics. Okay, using torque, calculate the mass of M that balances the system out. Okay, so we're going to say that our system is balanced at 50 centimeters. Okay, so you have like a ruler sort of thing going on, and you want to balance the system. Okay, so we need our forces. Okay, so the force of the weight is going to be mg. This is 1 times 9.8, which is 98 newtons. 9.8 newtons, sorry, 9.8 newtons. Now, this is going to act 50 centimeters away from the center. Okay, so 50 centimeters. And I want to go ahead and get into meters. So it's 0.5 meters. Now, we're looking for the mass of this object that is an octagon. Okay. And it is 12.5 centimeters away from this end. Okay, so let's figure out what this distance is right here. So we're going to do 50 minus 12.5. You get 37.5. So this is 37.5 centimeters, which is 0.375 meters. Okay, so we're going to balance the torques. So we're going to say that torque net, the net torque on something, is always equal to 0. Okay, so we orient our hand in the direction of the radius and we curl downward. So my thumb's going out of the page, so it's going to be positive. So this is going to be mg. Okay, we don't know what that force is, so it's going to be 9.8 M. Okay, and that's acting at 0.375 meters. We said it was positive. And then our other force that's acting is going to be the 9.8. It's acting at a radius of 0.5 meters. Now the reason it's negative, let's look at why it's negative. Okay, our radius is extending this way, and I'm curling in towards the bottom. I'm curling downward, and my thumb is pointing into the page. Okay, so what we can do is we can set this equal to 0, and we can solve. Okay, so we're going to do 9.8 times 0.5 divided by 9.8 and divided by 0.375. And so the mass is going to be 0.533 kilograms. Okay. These are good questions. They're hard, and it's not easy. Okay. So we got a system that looks like this. You know, this is like some sort of bar unit. And so we got forces that act here. We got two forces that act here. So we have multiple forces acting, and we have angles involved. So I want to find the net torque about this point right here. Okay. The first thing I'm going to do is anything at an angle, I need to break it down to components. So this 2.5 length bar is at a 45-degree angle. So I need to break this down into components. Okay, so 2.5 cosine of 45 is 1.7677 meters. And the sine of that is going to be 1.7677 meters. Okay. Now, we're going to work left to right from our point O. So the net torque. Okay, so if a system is balanced, the net torque is going to be 0. So they have something called equilibrium. You know, we talked about that. Equilibrium not only means that your forces are balanced, but your torques are balanced. So that's why we set that equal to 0. In this one, we want to find the net torque on the system. It's not at equilibrium. Okay, so first force we encounter going left to right is going to be the 600, and it's 1 meter away. Okay, so R times F. Now we need to determine the direction. So R is going this way, and my F is going downward, so it's going into the page, so it's negative. Okay, the next force we're going to encounter going left to right is going to be the 500, and it's perpendicular. Okay, so we're at a total distance of 4.7677 meters away, and my force is 500 newtons. Now we need to determine the direction. Okay, so my R is this total distance right here, and I'm curling upward, so my thumb is pointing outward, so it's going to be positive. That's the most important part of this question is the right-hand rule. Okay, then I have this force right here, this 300. And my radius is extending from here to here, and I'm curling towards the right. So you're gonna curl this way, and your thumb is gonna be pointing into the page. Let me do that again. So you're orient your hand this way. Sorry, I'm trying to get a look at the camera. And you're gonna curl your fingers that way, so your thumb is pointing into the page. So much easier in 3D. Okay, so this is going to be negative, and it's going to be 1.7677 times 300. Okay, so all we're going to do is put those numbers in the calculator, and we're done. So we're going to do negative 600 plus 4.7677 times 500. Minus 1.7677 times 300. Okay, you get 1253.54. It's going to be Newton meters, and it's going to be positive. Okay? Okay, last one. Okay, so what's different about this question is instead of giving angles, they're giving you little triangles, which I always wish I knew what this stuff meant. Okay? Now, when we go to break down these triangles, you don't actually have to find the angle. We're going to use our sine and cosine ratios from the triangles themselves. Okay? So, anytime we're at an angle, though, we're going to have to break it down into components. Okay, so in this case, we're doing perpendicular to a bar that's going this way. So there's really not any need to find this component. So we're looking for, let's say that's my angle that I'm looking for. So, or with respect to, because that's what this angle is. Okay, so if I'm looking for the sine component of this, it's going to be 4/5, opposite over hypotenuse. So 100 times 4/5 is going to be 80. Newton's going this way. If I want to find the cosine component, cosine is adjacent over hypotenuse, so it's 3/5. So 100 times 3/5 is 60 newtons, going that way. Okay, so let's do the same thing over here. Okay, so I got 50 newtons directed towards quadrant 4. Okay, so if I'm looking, so my angle is going to be right here. My angle is right here. Okay, so if I'm looking for the cosine component, okay, your cosine component is going to be, wait, did I do that right? I did that wrong. Hold up, I did that wrong. These should be switched. I'm losing it. Okay, so my sine component should be 80, and sine is going to be over here. So this is 80 newtons. This should be 60 newtons. Okay, and then if I'm doing, so because your sine is going to be your opposite over hypotenuse. Okay, on this one, this is our 50 newtons. So if we're doing our cosine component, which is going to be going this way, we're going to do adjacent over hypotenuse. So we're going to do 50 times 12 over 13. You get 46.15. Okay, if we're doing the sine component, we're going to do opposite over hypotenuse, so it's going to be 5 over 13 times 50, and you get 19.23. Now, we're not going to be paying attention to these x component forces because all our radiuses are in the x direction, so we're not going to have parallel directions. Okay, we need perpendicular. Okay, so we do our torque, our net torque, about point A. Our first force that we're going to encounter is the 60 Newton force. Okay, so we're going to do 1 times 60, and I'm going to curl this way, so it's going to be negative. And then the next force I'm going to encounter is 70 newtons at a distance of 1.75. Okay, and it's going to be negative also. Okay, and then the next force I'm going to encounter is going to be this one, this 46.15. It's going downward, and I'm going a distance of 2 meters away from here. Okay, so they're all negative. So 60, so negative 60 minus 1.75 times 70 minus 2 times 46.15. You get negative 274.15. 74.8. Let me double check my answer just to make sure. It's right. Oh, this should be right. Let me double check just to make sure. Angle is right here. They got 2. Wait, what did we get? The answers are below, so they got negative 295. Let's double check that again. So negative 60 minus 1.75 times 70 minus 2 times 46.15. I got negative 274.8. I don't really trust these people because the right hand rule was all off. Yeah, it's not that. Huh. Okay. Did I do this? I did this part. Okay, cosine would be. Wait, I think I switched these up. Hold up. The cosine component is going to be 12 over 13. No, I did that right. It's 12 over 13. The sine component is going to be 5 over 13. Okay, I think it's right. So let's stick with our answer of negative 274.8 newtons. Okay. So anyways, I'll work it out again just to confirm, and if I messed up on something, I will give you another video over this stuff. Thanks, and have a good day.